The next topic we are going to study is the topic of constructors. We have already learned about default constructors, so we are familiar with the idea of constructing objects. Consider the following code. We have class rectangle, which has two data members, length and width, LW. And in setup, we're calling the default constructor and constructing object R. So here we are constructing object R via default constructor. When we construct the default constructor, we said that R is created and L and W are set to 0. You see that here we are setting them to 10 and 2 respectively. If we wanted to have a constructor, we need to create the function constructor. So what is a constructor? Well, a constructor is a function that is used to initialize data members of an object. You will write constructors to guarantee that an object is always fully and correctly initialized when it is defined. And you can overload a constructor. That means that you can have multiple constructors. We have an example of a constructor here, class rectangle, and this is the constructor, rectangle, int A, int B. It takes two parameters. Now, rectangles, constructors do not have the return type, and they must be named the same as the name of the class. So, if we go back to our code, I could define a constructor here. So let me go ahead and define a constructor. So it has to be the same as the name of the class, rectangle. And constructors are functions that let us initialize our data members right off the bat. So we're going to have int A and int B. So it takes two parameters, and then it's going to initialize everything to the parameters that we take. So L can be set to A, and B can be set, W can be set to B. So if you look at this now, we can go down here, and instead of constructing the object and then setting the object to setting the member variables one by one, what I can do is I can do this. I can say rectangle R new rectangle. Now I'm not calling the default constructor anymore. Instead, I am calling the constructor that I have up here. So I'm going to say, let's make the sizes 10 and 5. So let's name this variable R1. Now this is going to create, if I go to my memory diagram, so here again the class is not loaded into memory until you create the object. So we have object R. So we have setup, we have R, and R inside of it is going to have L and W, and L is set to 10 right away, and W is set to 5. Simple as that. Now I said that constructors can be overloaded. What that means is that we can have more than one constructor for a class. So I can have another constructor. It must be named the same as the name of the class. So I must call the rectangle. And notice that it doesn't have a return type. So it's not void, it's not int. It just doesn't have a return type. And to this, maybe I'll just pass an A. Just pass one number, one integer. In this case, L is equal A. So I assign L to A, and I assign W to A as well. So maybe this would be if I wanted, this would be more of a, this would be a square, basically. So here, I'm going to have another rectangle, R2. Now R2 so now, just like overloading worked before, it's going to work the same here. Because we are only passing one parameter, the code, processing knows which constructor we want. So it knows that we want the constructor that only takes one integer, which is this constructor. So as a result, we are going to get this in memory. This would be R1. R2. We're also going to get L, which is going to be set to 7. And we're going to get W, which is also going to be set to 7. Now, one thing is really important. Remember the default constructor? Now that this class has its own constructors, it cannot use the default constructor anymore. So, if I came down here and I said, well, let's have rectangle R3, and I just want that created using the default constructor. Remember, the default constructor would create R3 and would set L and W to 0. I can't do that anymore. Because I have my own constructors, I cannot have the default constructor. If I still want some sort of a default constructor, or if I want a constructor that doesn't take any parameters, now I have to actually define it. So I would go here and I would say, okay, well, let's define another constructor. Let me actually write it down here. So I would say rectangle, and it's not going to take any values. And let's say inside, I'm just going to set L to 0, and I'm going to set W to 0. Now, you see that this is working because I've created it. Now it works. So if I wanted to see what this would look like in memory, it would be inside of setup. I would have R3. R3 would have L as 0, W as 0. By the way, this is my own constructor now, so I could set it to anything. So I could, for example, say set L to 11 and set W to 14, and I just initialize it like that just because I want to. So it'll work just as fine. It's running. So in this case, then R3, whenever you create an object, in this case, using this particular constructor, it's going to go here, and you're going to get L set to 11 and W set to 14. So that's just, it's just as easy as that. We've already learned all about default constructors. Constructors work just like default constructors, except that you get to initialize values.